Alright, so let's wrap up this subject by showing our corner build. And this block in the upper left is going to be our initial target cell. Our program channel is running like this, our control channel is running like this. This is our initial target cell, so the head cells are sitting right here. And remember, the configuration that we want looks like this. We want to route data like that. We want to route data west to south. We want to run data north to south. We want to take data from the west and send that into the control input. We have our feedback signal, which comes out like this. We have our subsequent feedback signal, which will come in from the south of the new program channel. That will get inverted and ANDed with the control channel input to pass on our control information. And it will get ANDed with its uninverted sense to generate control channel information that passes on to the south. So that's the system that we want to build, and I'm just going to go ahead and write my configuration steps inside here because it's only a 12-step sequence. It's not too bad. So step 1, control channel equals 0, program channel equals our usual attempt to control the cell to the east of the current head cell's target cell. So we configure this in step 1, and we set it up in a way that we have access over this cell in step 2. So in step 2, we're going to be configuring this cell. Sorry, this first one should have been control channel equals 1, of course. Step 2, we set our control channel equal to 0, and our program channel is just going to look like this. This is just a pre-clear step to clear this remote corner. Step 3, this cell will be configured. We're going to reconfigure this cell by setting CC equal to 1. And again, we set the program channel up to do what it was doing at the end of step 1. So we configure this. Step 4, we're going to return control channel to 0, which means this cell goes live, and we can now control this cell's configuration. So this upper right corner cell now goes into C mode. It's no longer asserting its C output. So we're only configuring this cell, but we're going to set our program channel up to be this OR configuration. With a 1 going into the control input. So that's our configuration in step 4. In step 5, we're going to configure this cell. And in step 5, actually, this cell will be being configured because this cell's C output to the south will be 1. But since this truth table contains zeros, we'll have zeros going into the OR gate. And since this cell is in C mode, zeros will be coming into the OR gate from the west, and we'll end up just sending zeros in. So in step 5, we're still just we're not changing the truth table value here. I'm not marking it as a pre-clear because we're not explicitly writing zeros in. We're just preserving it, and it happens to have all zeros in it right now. So step 5, control channel equals 1, and we want to actually prepare to configure this with some desired information. So our program channel equals, and it looks like steps 1 and 3, but we don't assert the C output. We just take data from the west and pass it to the east. So in step 5, we configure this to move data from one side to the other. And then in step 6, we return the control channel to 0. Now this is in D mode. This is in D mode. Its C output goes live, and it's configuring this cell. So in step 6, this will be configured. And the truth table that we're going to send in is our desired configuration, which takes data from the west, passes it to the south's control output, and passes data from north to south. And that will put this cell into its final configuration. So we've done the hard part. We've configured the remote corner. Step 7, put the control channel to 1 and set the program channel to our usual configuration for configuring the cell to the east. So in step 7 we configure this, but note that in step 7 this cell is again being configured into its final configuration. And then in step 8, set the control channel to 0, which means we'll be configuring this cell, and set the program channel to our final configuration, which looks like this. And so that's this cell's final configuration. Now we've configured both of these cells. Steps 9 through 11 are our standard 3-step sequence for configuring the target and the cell to its south. So step 9, control channel equals 1, program channel equals, take data, route it to the south, put a 1 into the south's control north input. Step 10, load in the desired truth table, which looks like this. And places this cell in its final configuration. And then 11, load in our desired final configuration up here with the all-important feedback signal going out to the south. And then 12 is our quiescent period, where we go ahead and we simply let this cell return into D mode. As long as we momentarily enter D mode in this cell, the one output will come out to the south. That will stop this previous set of head cells from acting like head cells. C information will be passed down here, and we'll move the head of the wire from here to here. And so 12-step sequence gets us a corner, and then we can begin configuring cells moving from a north to south direction. So that's how we change direction in our wire building sequence.